Ladies and gentlemen, boys and girls, children of all ages, we're going to look at a few problems from Spiral Review 17. Our first problem is a road crew spread 1/3 of a ton of gravel evenly over 3 feet of road. How many tons of gravel did they spread on each foot of road? Explain how you found your answer. Well, a few things we need to think about first. We have a total gravel is 1/3 of a ton. Now, some of the ones I've been getting back are telling me that they're putting a whole ton on each foot. We only have 1/3 of a ton to start with, and we got to carry that on 3 feet. 3 feet of the road. R-O-A-D. So we have 1/3 of a ton of gravel total. We don't have a whole ton. We have 1/3 of a ton of gravel, and we need to spread it among 3 feet. So here's my ton. This is 1 whole ton of gravel. This is 1 ton. And I need to split that 1 ton among 3 feet. Okay? So I'm going to have 1/3 of a ton of gravel, what I start with, and I'm dividing that amongst 3 feet. So I have a unit fraction divided by a whole number. So here's my 1 ton. This is the ton, this is the part of a ton that I have. I don't have all of it, I only have this part. And I need to split that part evenly between 3 sections. So 1 foot is going to get this section right here. So it is 1/3 of 1/3 is what I'm really getting. 1/3 of 1/3. Well, what is 1/3 of 1/3? Well, I'm finding 1/3 of 1/3 is basically what we're doing. But if I divide each of those thirds evenly into 3 parts, I have 1 out of 9 total parts. So 1/3 divided by 3 is going to give me 1/9. 1/3 divided by 3 is going to give me 1/9. When I'm dividing and I have unit fractions and I have whole numbers, all I need to do is figure out what is being broken apart. Here, I know I need to split the 1/3 of gravel. So since I'm breaking the gravel apart, not putting together, I'm breaking it apart, that's what's being divided. If I start with a unit fraction and divide it by a whole number, my answer is a unit fraction. If I start with a unit fraction, divide it by a whole number, my answer is going to be a unit fraction. So they're only putting 1/9 on each foot of the road, 1/9 of a ton. Here's a different problem we have here. How many prime numbers are there between 20 and 30? I'm not going to count 20 and 30 because it says between 20 and 30. So we have the numbers 21, 22, 23, 24, 25, 26, 27, 28, and 29. So these are all the numbers between 20 and 30. Now, I know that a prime number, there's only one prime number that is even, and that is the number 2. That is the only even prime number there is. So that means 22. Since it's an even number, it can't be prime. The only even number there's prime is 2. 24, 26, and 28 are not prime numbers because they're even numbers. So now let's look. A prime number, if we remember, has only 2 factors. 1 in itself. So let's look at the number 21. The factors of 21, we have 1 and 21. Does anything else divide evenly into 21? Well, yes, 3 and 7. So that makes 21 composite. If it has more than 2 factors, it's a composite number. So let's take 23. Always has 1 in itself, so 1 and 23. Is there anything else besides 1 and 23 that will divide evenly into 23? And the answer is no. So this one's prime. 23 is prime. 25. Well, I have 1 and 25. Since it has a 5 in the ones place, I also know it's divisible by 5. So this one's composite. And we have 27. 27. Well, I know it's 1 and 27. And I know it's not even, so the number 2 doesn't divide evenly into it. But if I add my digits together, 2 plus 7 is 9. 9 is a multiple of 3. So that means 3 times something will be 27. Well, that's 9. 3 times 9 is 27, so 27 is not. We're left with one last one. The number 29. Well, it always has 1 and 29. And that is it. So the prime numbers between 20 and 30 are 23 and 29. So there's only 2 of them between 20 and 30 that are prime. And this is how you figure it out. Find the factors, the numbers that will divide evenly into a given number, or 2 numbers that multiply together, factor pairs, they multiply together to equal that number. All right, Mrs. King is putting pudding into small containers for a party. She has 12 cups of pudding. So she starts with 12 cups of pudding. She puts 1/3 of a cup of pudding in each container. Which equation could be used to find the number of containers she can fill? So now we're filling up containers. We're not going to fill up 1/36 of a container. That doesn't make any sense whatsoever. So now we have to think, are we filling 4 containers, 12 containers, or 36 containers? If we use a little logic, we have 12 cups. 1/3 of a cup in each container. So we have 12 cups, 1/3 of a cup in each container. So if we have 1 cup, it's going to equal 3 containers. 2 cups equals 6 containers. So if we go on that pattern, we're going to end up where it's 36 containers. So what we did is we started with our 12 cups and we divided that into groups of 3. So we have a whole number divided by a unit fraction. This is asking how many thirds are there in 12. So there are 3/3 in 1, 6/3 in 2, 9/3 in 3. So it's asking how many thirds are there in 12. A whole number divided by a unit fraction equals a whole number. So a whole number, 12, divided by 1/3 equals 36. Okay, so there's 36 containers. You can put 36 containers of pudding. Now, Miss King and her pudding. She's putting pudding in containers. Let's try. Okay, here's another one. Charlie's soccer team has the following jersey numbers. Griffin, 19. Dalton, 13. Greg, 17. Charlie, 15. Bennett, 26. And Jasper, 23. Which of the players have jersey numbers that are prime numbers, and how do you know? Well, we've already talked about prime numbers before. We know the only prime number that is even is 2. So 26. So Bennett cannot have a prime number. 19, if we have 19. 1 and 19. I can't think of anything else. So Griffin is prime. 13. The only ones I can think of for 13 are 1 and 13. So Dalton would be prime. Dalton is prime. Greg is 17. There's nothing else that multiplies together to equal 17 besides 1 and 17. So Greg is prime. Now I can eliminate Charlie because Charlie has a 5 in the ones place. Since Charlie has a 5 in the ones place, that means 5 times something will equal 15. So we'll have 1 times 15 and 3 times 5. So I know that, and then Jasper's prime. So my answer says which of the players, my answer would be Griffin, Dalton, Greg, and Jasper. I mean, I know 23, we just did that on a previous problem. So that's easy peasy raw chicken squeezy. Draw a model 1/3 divided by 7. 1/3 divided by 7. So now I have a unit fraction divided by a whole number, which means my answer is going to be a unit fraction. A unit fraction, because it has a number 1 as its numerator, divided by a whole number means my answer is going to be a unit fraction. So if we take and we have 1/3, each of these is worth 1/3. But we're taking one of them and dividing it into 7 equal parts. If we do that, this is how much we're talking about. This 1 out of how many parts would there be if all of them were divided this way? There are a total of 21 parts. 1 out of the 21 is what we're looking for. So a model representing 1/3 divided by 7. I had my 1/3. I divided my 1/3 into 7 equal pieces. One of those pieces would have the value of 1/21. 1/21. A unit fraction divided by a whole number gives me a unit fraction. Now this is different. This is 7 divided by 1/3, which means it's a whole number divided by a unit fraction. So 7 divided by 1/3 tells me my answer is going to be a whole number. It's asking how many thirds are there in 7. So if I have 1 whole, so this is 1. 1 whole has 3 thirds. 2 wholes, 6 thirds. 3 wholes, 9 thirds. 4 wholes, 12. 5, 15, 6, 18, 7 is 21. This is asking, if I take 7 and divide it into thirds, how many thirds will I have? So how many thirds are in 7 is what this is asking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 7 divided by 1/3 is 21. 7 divided by 1/3 equals 21. Whole number divided by a unit fraction equals a whole number. A unit fraction divided by a whole number equals a unit fraction.